So now let's talk about some of the common challenges that every data engineer face in the day-to-day basis and how we can overcome them very easily. So the first one is data ingestion challenges. So this is like every data engineer face more often because data ingestion is the most important step for every data engineer. So basically your data could be coming from various sources. It needs to be transformed to able to extract meaning out of it. So let's say if your data is coming from any structured data sources, then that data should be already in a row and column format. So processing that data may not require that much groundwork, but let's say if your data is coming from a website log at a real time, so you have to process that data to able to convert it into the more readable and more analysis friendly format. So let's say if you want to convert it into the structure format, it needs different set of transformation and operation, and also every data field should have its specific format. So if you are extracting the dates, it should be present in a specific date format and matches across your data platform. So the different date fields coming from different sources should have the same format, so that if some end user or a data scientist is querying on top of the data, it should not mess up with the format and gives us the incorrect results. So that is very important to maintain the integrity of the data, because if you have inconsistency in your data set, then it can lead to wrong analysis of the data, and it could extract like the different meaning that you don't require. So to overcome this, you have to first think about what are the different sources from which you are pulling the data, what is the right format. So I already talked about it that data cataloging is very important. So you should be having a high level architecture of like from where you are pulling the data, which fields you are pulling the data, what is the format of those fields, so that you will be having the whole idea of your architecture. So the next one is the data integration challenges. So this is also very important. So let's say if you are having a Hadoop ecosystem and all your tools are well integrated within the system, but if you want to add one more tool in your bucket, let's say if you want to add ELK or graph databases in your Hadoop ecosystem, because Hadoop ecosystem don't native graph database or like the platform like ELK. So to leverage that, you have to make sure that you have the right connectors, the version of your Hadoop is matching to that connector, and because connector will vary as per the version of two tools that you are going to integrate, and it acts as a bridge between integration of these two tools. And also like you should be having your data in a certain format that the connector or integrator can able to read it and convert it as per your target tool or technology. So that's why data integration will have a lot of challenges because of the various structure. So let's say if you are dealing with the graph databases stores the data as a node and relationship, and Hadoop will generally have the structured data. So converting the structured data to the graph databases and having like the integration between this system is pretty difficult task. So this is how you have to think about all the things that can go wrong and how we can solve them while integrating the different tools which are not an integral part of that ecosystem. The next one is also pretty common, like the storage challenges, because as your data will grow day by day, and if you are handling big data, you will struggle with these storage challenges. So let's say if your tool is deployed and working in parallel across 4 nodes, so basically it will have the 4 virtual machines and your program will be installed on top of that, and these are communicating with each other. But let's say if you are onboarding multiple use cases day by day, your storage will suffer, your RAM will suffer, and the available memory for analytics will also suffer. So you have to think about the storage solution as per the amount of data that you are going to input into this data storage, and also having the right file format. So let's say if all your files are stored in CSV, then you are screwed, because CSV and JSON formats are pretty readable, but they can consume a lot of memory. So you should be aware about the more storage friendly solutions like the Parquet format, Avro format, which are compressed and takes a way lesser capacity. And also you should be having the track of where the data is stored. So since you will be having like multiple data sources, managing this all this and maintaining the directory of these data sets are pretty difficult. So you have to make sure that you have the right process to store the metadata of all your data workloads and the data files, and they should be in the right format so that the reading and writing operations are way more efficient and also storage efficient. The next one is the data processing challenges. So this is also very common. So let's say you're handling like thousands of records every day, so you can utilize pandas data frame to able to process the data to get it into the required format. But let's say if you are handling like a millions of records or the billions of records, then pandas will not work. So you have to convert your pandas workloads into pyspark or the Hadoop. So to able to do that, it should require you that the output of the data is as precise as you are getting in the pandas. So you have to think about all the functions, the transformation which requires in the Apache Spark to convert it seamlessly and get the required output in a more efficient way. So that Apache Spark is a pretty popular tool in the big data, and we have learned all about it in the previous lecture. So handling big data is a piece of cake for Apache Spark. And also if you are handling the data which is not in the structured format, then utilizing the tools and technologies in the Hadoop is also good. And there are a few use cases where the MapReduce is better choice as compared to the Apache Spark. So it totally depends on the volume of data that you are handling and what is the output that you require at the end of the day. So for handling the JSON files, maybe instead of Spark you can rely on the MongoDB, because it is a document based database having the structure like a JSON format. And also if your workload needs a very highly available system which is like mission critical, then you can also think about the Cassandra. So you have to think about your data processing strategies and which tools are more suitable for your use case. And the last one is data quality and the governance, because some of the organizations are utilizing the sensitive information like the PII information of a user or their customers, as well as the healthcare information of a patient. So this data is pretty sensitive and this should not go outside your organization. So you should be having the governance strategies in place to protect the data and maintain as well as maintaining the integrity and accessibility of the data to able to process your data seamlessly. And also we have already talked about the data quality. So you should be having the integrity of your data in place, and the data should be coming at a right format, and you don't have the inconsistency of your data, because it leads to the wrong analysis and meaning of your data, and you don't want that because it will impact the decision making capability of your data solution. So these are all the common